Hello, everyone. Um, I'm so happy to be here. I'm like genuinely thrilled to be able to speak to your beautiful faces. Yeah, so let's get started. So, I'm Faduma. I'm a software engineer at Condé Nast, and I love GraphQL. So if you have any GraphQL questions for me, you can send them through to that handle. Okay. So, what is Condé Nast? So, lots of people don't know who who the hell Condé Nast is. It's a very like obscure sort of company. Condé Nast is a publishing company that owns major brands that you probably know of, like GQ and Vogue. And this is the beautiful Vogue website that I helped to build. So yeah, that's who Condé Nast is. So what I'm going to be talking about. So I'm going to be talking about I'm hopefully going to answer the question, what the fudge cake is GraphQL. And in doing so, I'm going to talk about those two topics, which is like REST versus GraphQL and the benefits of GraphQL. But before I do this, I really want to make sure that I ground GraphQL in like sort of the real world, make sure everybody knows what I'm actually talking about. And to be able to do that, I have to talk about the internet. What is the internet? What is the internet? So, the internet is a big collection of computers basically talking to each other. It's not really magic, it's just one computer talking to another computer. And when I say computer, I mean either your laptop or your phone connected through your Wi-Fi, using your internet provider, and then communicating to millions of computers around the world. That's what I mean. And these are based on a set of protocols, rules. And these rules are the most important part of the internet. Communication is the basis of the internet, and it's going to be a theme throughout my talk, how things talk to each other. So what are these rules? So these rules were created in 1989 by Tim Berners-Lee when he put out a proposal for the World Wide Web. And one of the rules that he set out was the HTTP protocol, which stands for Hypertext Transfer Protocol. This protocol powers all web pages. The HTTP protocol defines how computers should talk to each other. And this communication, where one computer is talking to each other and the other one is responding, is called the HTTP request and response cycle. So, for example, if I went to Vogue Germany website, I went to the beauty page, what will be happening behind the scenes is that I would be going to a browser, which is a program on my computer, going to a URL, and that URL will make a request to a server, which is another computer, but it's just dedicated to receive requests. And that server will then make a request to a database of some kind, and then stitch up all the information into a page and send it back to your personal computer. So that's the request response cycle, and this is sort of the basis of the internet. So what does a HTTP request contain? It contains sort of like information. It contains things like headers, host names, and requests. And these are just like a standard set of ways that computers communicate. Every time that you make a HTTP request, some of this data will be included. So what is a request verb? So a verb tells the server what to do with the information that you're requesting. So you can when you go to a URL, you can attach it to a verb such as get, and then the server knows, actually, okay, I'm going to go get some information from somewhere. Or you can tell it, actually, post to this URL and give it some payload, and then it knows, actually, okay, so I'm going to get this data, and then I'm going to save it somewhere else. So a get here, when you make a get request, the URL is sort of basically enough information for the server to get started with what it needs to do. You don't need to send any extra information. And but with a post request, when you send a post request to a URL, you attach sort of a payload, which is like extra information or a set of like a structure of data you want to be saved somewhere else. So what does a HTTP response contain? It contains also a set of information. So there's always like standard ways for computers to communicate with each other. So a HTTP response will probably have like something like a status code and a HTML page. So if you go again to that website, that URL, you might get back the actual page, which is HTML, and then also a status code, which tells you everything is okay, which is 200. If you want to see this state like response request and interrogate it a little bit more, you can go in your browser, sort of dev tools, and go to the network tab, and then click on XHR, and you can see that you got, when you went to the website, you got a response with a HTML and a little sort of status code telling you everything is okay. So this request response cycle is, like I said, basis of everything, really important. However, what if your website starts growing? So now, not only do I have one page, I have like several different pages, and maybe I have loads of different people going to those pages. So now, every time somebody goes to that website, it has to make this sort of loop, right? It has to go to the server has to get data, and then it has to send it back to a page. This is slightly inefficient. There needs to be a little bit more efficiency as to how we share that sort of data we have. And we might want to be able to share the data without having to share all the code. So what if I want to organize my server-side code to be a little bit better, so I can have where separation of where the data exists and the view. So that's probably what I want. So I want the presentational, which is like what people see, and the data to live slightly separately. So there's a little bit of separation of concerns there. So how do I tackle this problem? A key tool to tackle this problem is something called Application Programming Interface, which is an API. And what is an API? API, the term refers to sort of a web URLs that can access raw data. So API URLs might look like that, which is very similar to the page URLs I had previously. But you're still making a request from a client using the HTTP protocol. So it's still communicating in the exact same way it was doing before. But instead now, instead of getting back a web page like that, you're getting back JSON, which is sort of structured data. It's structured in a key value pair notation, basically. So JSON might look like that. So now an API, make a request to a URL with a verb, but instead of getting back a web page, you get back JSON or some raw data. Yeah, like I said, you're still making a request to an endpoint, and you get a predefined set of data that someone has determined should we get back from that request. This is what an API basically is. However, there's a pattern, right? So if you look at the API URLs I have, there's sort of a pattern there, right? It's and this pattern gets me to the next bit of my discussion. What is a REST API? A REST API is a REST API stands for Representational State Transfer, and it's just a way of organizing your data in different resources. So if go back to the API URLs, you see that I've organized it in separate sort of resources. So I've done beauty in a separate little corner, fashion, shoes, makeup. It's just like organizing your data in something similar to each other. So REST is basically just a style of organizing your software. It sounds great, doesn't it? We're separating out our concerns. Now we have presentational layer, and we have a data layer where we're just getting data back. And we have a way to organize that API. So it's still making that sort of request response cycle, but instead now, not only do I have a website, but I have an API sort of server or endpoint. So life is good. We're chilling with our REST world. But there's some problems with REST APIs that I'm going to discuss. So the first problem with a REST API is that you might find when you start building and getting a little bit more complicated is that the client application, so the application that is responsible for doing sort of the presentational or the view layer, and then the HTML thing that looks like the website, has to make multiple requests to this API endpoint. So remember our little API URLs. What if we wanted to make a page that included both fashion and makeup, and we wanted to get data back from somewhere? We would have to make a request to both the fashion endpoint and then the makeup endpoint, and then squish that data together and then add it to the page. This is not really a great way of communicating. Now I'm just making like several requests. I'm not exactly getting what I wanted. And if you make multiple requests in your client side, it's not very performant. There's a bit of a cognitive overload. Like the developer has to start thinking, actually, where does all this data exist? Like, oh, do I have to go to that endpoint and then that endpoint? It's a lot of cognitive overload. Another problem that exists with REST APIs is that a lot of data, you're making requests for a lot of data that you might not need. Because the data is sort of structured and it's preset by the developer, it doesn't really quite meet your needs, or is a bit overloaded. And you get back a lot of unnecessary data. So this is actually a screenshot of one of our REST APIs, Condé. And you can see that's a lot of data I'm getting back. And it's very challenging to figure out where exactly the piece of information that I want exists. So what is wrong with this? It's really confusing. It's confusing clutter. Like, that is a lot. And it affects performance because the browser has to download all this information. And it can be a security risk. What if the API developer introduces a sensitive field and you're not really, taking care of that? So the moral of the story is that all this data should not be sent to the client, which is the front-end application. And some of the data might not be in a format you require. So you might get things in Markdown, which is not really great, because then I have to transform it into something different. And it's because the reason why I'm getting things that are in a different way that I want it is because it's not really built for a specific person's view mind. So if you're consuming like a third-party application by Google hasn't created it just for your personal needs. So you have to adapt to what that company and those developers have decided. Another issue with sort of REST APIs is documentation. Like, where do I find out where all the URLs exist? It really puts the onus on the API developer to make sure they're documenting everything. Like, what data am I getting back? Sometimes you have to actually make a request to the API to figure out what data you're going to get back, so you can attach it to your view layer. And documentation is hard, especially when it's done by humans. So I'm not really downplaying that difficulty. So how do we solve these problems? GraphQL, maybe? So that gets into what GraphQL is. The GraphQL is defined as a query language for APIs. So GraphQL is like a language for requesting data from your server. So it creates a different way to communicate with your server. So what is the difference between like a REST API and like a GraphQL API? First, so with REST, like you've seen, there's multiple endpoints, while GraphiQL has a single multi-purpose endpoint. Another difference is that with REST endpoints, it gives you a predefined set of data, while GraphQL allows you to query describing what you want. So if you were using a REST API, this is sort of like the cycle that you would get through. So your client application would make a HTTP GET request to your server, to a particular endpoint, and then at that endpoint would just give you back the data attached to that endpoint. So it would give you predefined data. For example, for this request, you're requesting user for a particular user, so you're going to get everything that developer decided would you need for that user. And that's similar for posts and followers. So you have to make multiple requests for different information. So if you had a page that was, showing both the user's information plus, the followers and the posts, then you have to make these multiple requests and get all those data and then figure out which ones you need. Well, in comparison, with a GraphQL endpoint, you instead make a HTTP post request. So you're asking for a particular thing. You're saying, actually, I want something slightly different. And you're making it to just one endpoint. So with GraphQL, you make a query. So you structure your data that you want before it hits the server. So the front end, the client, is saying, actually, for the user with a particular ID, I want the name, the post, the title, the followers, and I want the last 3 followers, and I want the name. So you don't have to then just rely on data coming back to you and then having to decide which ones follow those rules. So you're upfront requesting a certain structure, and then you're going to get it back in that sort of structure. So yeah, GraphQL gives you exactly what you want, no more or less. It's a little bit more flexible and efficient approach than REST APIs. Another difference with GraphQL and REST is that there's a schema that tells you which fields that you can request. And I'm going to show you a bit of code now, so don't get scared. But this is what a GraphQL schema looks like. So here, you see here, I'm creating a schema. This is just a basic GraphQL using the Facebook tool that they created. So created a new GraphQL, and I'm defining my root query, which is the fields in my root query are users, and it's going to return a user type. And the arguments are ID, which is a GraphQL ID. So what is user type? I've defined what user type is there. User type has fields, which is ID and name. And this is sort of I'm defining the structure of my API in this way. Like I said, that's the root query where you're defining the entry point for anyone to make a request. So like other languages, right, like JavaScript or Python, there's tools to make this creation of a schema slightly more easier. So there's companies like Apollo and Relay that do lots of developer tools that help make it slightly more easier and look prettier. So instead of your schema looking like that, it can look like this, which is slightly more neater. So there's still that's the whole instantiating a new GraphQL and etc. still happening, but now it just looks slightly better and much more easier to consume. Another difference between a GraphQL and a REST API is that each field for GraphQL API has a resolver function attached to it. And what I mean by a resolver function is basically just that. So every time you create sort of a field in your schema, there's a function that you can attach to it that gets that data. So here you can see in the user field, there's a resolver that gets the ID and then hits a database and fetches the users from that database and then returns that in when you make that request for that field. While REST routes have a slightly different way of organizing this. They have controllers and handler functions. So this is what a REST endpoint in your backend might look like. So you're defining the GET request with the URL, and you say every time when somebody hits that URL, please do this, run this piece of code. And the piece of code is attached right there, and it's making it's going to a user model, which is like a database, to find this user, and then it's sending back with the status 200 and in JSON format. It's a slightly different way of looking at it. Related to that, with GraphQL APIs, a benefit that you get is that relationships between data is slightly more clearer. So if you remember this sort of that request, how do I know what the user has? Like, does the user have followers? Does it have posts? What does the user actually consist of? To be able to find this out, I have to go to the user model and look at the database schema. I don't get this information quite up front. Well, on GraphQL is simpler. So here, when I define the user, and I said that is going to return back a user type, you can see here there's posts. And that is a relationship that I've created between those two data. I've said users have posts, and a post is defined right underneath it with, and it contains a title and author. So I know when I make a request to the user and I say I want the field for a post, I'm going to get multiple posts attached to that particular user. So GraphQL is just basically a different way of representing your API data. So what are the benefits that GraphQL gives you? First of all, you get instant documentation. GraphQL ecosystem has tools to generate documentation from your schema. So that schema that I showed you, GraphQL has like little tools that attach to your schema and then create a documentation for people that are consuming your API. So these tools are, there's two particular ones. There's GraphQL and GraphQL Playground, which are really good to interrogate your GraphQL endpoint and see the schema documentation. So this is actually Condé's, our endpoint and the schema that we have. So here you can see that in our schema, there's several queries you can make. So there's several requests that you can make, such as articles. You can request categories, etc. You can request galleries and navigation. And you can see here, when I make a query for the article, I can clearly see what data I have to give it. So the arguments I have to send it back, I have to either send a slug or the brand and the market. And I'm doing that right on the other side. So you can see here, I'm defining a slug, market, brand, and I'm making a request for that one particular field, which is ID. And I know this because I can see it just there, which is what I'm going to get back from the request. So these are all the data that I have available to me. And I can go say, actually, I just want ID. Or another time when I make a request, I can say, actually, I just want deck and a tout. I don't want nothing else. And GraphQL allows you to do that. So now, personally for Condé, our documentation is actually now useful and it stays up to date without no effort. Another great benefit with GraphQL is that it encourages good patterns of structuring your API. It allows people to just fetch the data you actually need. And you can do this without GraphQL. Like, there's other programming patterns that encourage these principles, such as domain-driven design and hexagonal architecture. But GraphQL enforces these patterns without requiring developers to police themselves. So you don't have to, when a person makes a pull request or you're doing a code review, you don't have to be like, actually, you haven't followed the patterns. GraphQL just encourages you to do that way because you have to do it that way. So it allows you to follow these patterns without having to actually think about it. So, that was interesting. Okay, so why might you use GraphQL? You might want to use GraphQL if you have a set of data that needs to serve multiple applications. And what I mean by that is perhaps you have a web page and a mobile application, a mobile app, and You need to make sure this API serves both of them without having to do lots of transformation. So GraphQL is why I think GraphQL is really product friendly. So it allows you to create products very easily because the entry point for consuming your application is much lower. And it reduces the burden of consumers to actually perform lots of logic. So if this API had to serve both of them, the code to transform the data would exist in both the web page, the application, and the mobile app as well. But with GraphQL, you can add a sort of a layer between this content API. So this content API can chill right there, and you can have a GraphQL layer that consumes from it, but then sends the data to both of these applications. And now the business logic, instead of existing, so the business logic, which is the logic to like transform the data, doesn't need to exist in both the web page and the mobile app. It can exist in one place, but serve both of those needs. So it doesn't enforce a specific way for you to consume an API. It gives consumers the flexibility to request data in the way that they want. So how would a GraphQL endpoint actually provide this need? So if, for example, I had the web page and I was making a query, so this is a category page, so it just shows loads of articles in a particular category, or anything in a particular category. So I'm making a category query with a slug, which is a URL or like a path name, and which is beauty. And here I'm actually requesting the fields, which are articles and certain fields attached to articles. But using the same query, I can use it slightly differently for a mobile app. So instead of making a request for articles, I'm making a requesting images instead. So I'm using the exactly same query, but here I'm just saying, actually, the data that I need as a mobile app is just images with the URL alt. I don't need the articles. So it gives you a little bit more flexibility. So your application could be totally different, but seamlessly use the same set of data. Another reason you might want to use GraphQL is that if you're building an application that uses multiple data sources. So scenario, so if Condé Nast introduced like a extra data source, so now we have a shoes API or feeds of shoes, what will happen? So here now I have the content one that just sends me back the categories and all the articles, and I've introduced the new Rainbow API, which has feeds of shoes. How would my web page here interact with both of them? You can build a GraphQL layer to fetch data from both of these sources, and then combine the data. So this GraphQL layer will combine the data from any of those sources, but you only have to interact with one endpoint. GraphQL and REST are not mutually exclusive, so you can get data from lots of places, including REST. So you don't have to replace all your REST APIs with GraphQL. You can build a GraphQL API that consumes from a REST API, from other GraphQL APIs, from a database, from a JSON in your file system, etc. So here, this sort of consumption here, this GraphQL layer is the only thing that's interacting with these two sort of like API data sources I have. And your resolver function will handle all this complication behind the scene. So the only part that knows about this complication is that GraphQL layer. Meanwhile, your front end is living its sweet GraphQL life. Another reason why you might want to use GraphQL is that you want to enforce structure to your code base. GraphQL encourages good habits. It helps you separate out your concerns, encourages you to remove logic specific from third-party APIs from your actual client application. Another good reason why you might want to use GraphQL is that is that you might have built a REST API, like a pseudo GraphQL API anyway. So what I mean by that is this. So you have an endpoint that fetches fields based on a query parameter. So it might look like that. So you're making a request to this URL, has ID, and you have different parameters, such as country, and then fields, which is name and avatar and post. It's basically GraphQL already. Doesn't it look better like that? It looks a little bit better, doesn't it? Instead of making constructing a URL with all this information. So why not just make it GraphQL? So how do you get started? There's several places where you can get started and try out GraphQL APIs, such as the actual GraphQL website. There's How to GraphQL. There's Prisma, which is a really good tool for helping you get started with your first tutorial. Thank you. That's my talk. Yeah.